Hey, so excited to talk about my MIT project. Making this video primarily for my portfolio website, just to show some of the work that I've done. I'll post any files or code there if you want to dive a little bit deeper into this. Facial emotion detection project, just to kind of lay the background a little bit. Communication is over half body language and facial emotion. The other less than half is the actual verbal communication that goes on. A lot can be detected by body language and by facial expressions. My final project in my MIT program was to utilize machine learning to be able to classify human emotions by training a machine learning model to do that. I was able to test a lot of models. The issue at hand is what's the best model to use and what are some of the parameters that we can use to maximize that model's efficiency. So accuracy, efficiency, again, parameters, and how can we kind of toggle those. Overall, facial emotions important. We wanted to answer the question of what's the right model for the job. Well, my approach was first to become familiar with the data and distribution. I was provided with training and test data from MIT, and there were thousands of images of four different classes: happy, neutral, sad, and surprised. Had thousands of images for each of those classes to be able to feed into the model to train it. I tested a basic convolutional neural network and compared color grade versus grayscale, and moved on to a slightly larger CNN architecture to see how that impacted performance. Then I looked at transfer learning architecture, so pre-trained models trained on other foreign data, and we're going to bring it into our ecosystem, so to speak, and see how it performs being trained with our data. So the last model that I experimented with was a more complex neural network architecture that included 5 blocks or layers, and then I'll provide a final assessment and recommendation. And then through a lot of these, as I compared different models and then moved on to the next one, there's a lot of evaluating and comparing. My approach was, all right, what's the best model so far overall? That's what I'm going to compare the next model to. So some of the key findings here: the image is distributed fairly evenly, and it came in really clean. There wasn't a lot of pre-processing I had to do, which was nice. They were all the same size. They were all grayscale. Some definitely higher quality than others. You can see here the surprised images. There are about 800 less of those than the rest of the classes, but that didn't prove to make all that big of a difference. So with the initial convolutional neural network, did a pretty simple architecture here, just comparing color to grayscale. So that was the one, independent variable that was tweaked to see how the other dependent variables reacted to that. And so you can see here, there's a few concerning things as you look at training and how it did on training and validation. The blue line represents how it did on training data. So as is expected, as it continued training through each epoch, it got more and more accurate on the training data, right? So it's learning, on the training data, and it's getting better at that. But what's concerning is the inconsistency and direction of accuracy of the validation data. So data that it hadn't seen before, how does it perform? That's really the more important metric. But I pointed out these two convergences here to show that once the model starts performing worse on the test data, but it's still continuing to do better on training data, that's a big red flag of overfitting. And so it's becoming really fit and closely tied to the data that it's being trained on. But when it's exposed to new data, it doesn't perform as well because it is so closely tied to that training data. I decided to move forward with the grayscale, just because all the images are grayscale anyways. I didn't see a need for color, and there's not a huge difference in terms of accuracy or overall performance. They ended up performing pretty similarly. Did a slightly larger architecture, again, convolutional neural network. So there's hidden layers in between the input and output that transform the data and train as it goes. This is a bar graph showing accuracy. So this is the original grayscale CNN, and this is the CNN grayscale with a larger architecture. So just a slight improvement with accuracy. Not great still, 60% accuracy, that we want to get higher than that, but we're making progress and it's better. So it's the new benchmark. Moving into these transfer learning models, again, the purpose of these is efficiency. Diving first into VGG16, this was a pretty deceptive model. First, I was like super excited because it had 84% accuracy. I was like, wow, that is incredibly accurate. Over 20% larger than the next best thing, which was our benchmark of the larger architecture CNN model. But after looking at, again, the training and validation accuracy, you can see that it's overfitted. There's a huge discrepancy as it's being trained between the training and validation data. And again, you see this convergence. You can see the trend here that it's the validation accuracy is coming down while the training's coming up. So it's overfitting to the training data. The ResNet V2 model, the trend is better here, right? The test data isn't experiencing quite as much of a drop off. The alarming thing here is with the training accuracy, it's already starting to plateau pretty early on in the training process. Like it jumps out to a good start, and then it's already slowing down, and you'd like to see that continue to go up and taper off more up here in the 70-80% range. It's already starting to taper off at 50%. That indicates underfitting, right? It's not able to really recognize patterns that are consistent within the data. The validation accuracy is just kind of all over the place, pretty random, up and down. Had, decent accuracy, decent fitting, but still wasn't great, isn't reliable for this use case. And then lastly, the EfficientNet model trained extremely quickly, but the accuracy was just nowhere near where it should be. And this is compared to VGZ16, but still, it's like 25% accuracy. You might as well flip a four-edged coin, I guess, to decide what emotion is on a screen, just not up to par on accuracy. So lastly was the 5-block convolutional neural network. So this was a more complicated, more layered, intricate machine learning model, and it paid off. Took a long time to train, but you can see the trend here looks much, much better than the transfer learning architectures. There is this little dip here in test accuracy, but then it shoots right back up with the next epoch, so I'm not too concerned there. It's tapering off up around, starting to taper off around 70%, so more accurate than the larger architecture CNN that was built on top of that original Grayscale CNN. And it's not really overfitted or underfitted, right? The training and test data are pretty closely aligned throughout this whole process. And if I did more epochs, it would show, that continues to grow and trend in the right direction. Just a strong balance of fit and accuracy. Obviously, accuracy wasn't off the charts. It wasn't 95%, 90%. I think with more training, it could get there. In terms of fit, a really solid architecture here that you could rely, and you could expose this to new data and feel pretty good about what it's going to predict. Over here on the right is the confusion matrix. Everything in this diagonal line here is the correct predictions. And so you can see, these are really dark compared to the other squares. That indicates, a higher number of correct, accurate predictions. And it's performing quite well, and it's well fitted. So no surprise, I recommend the 5-block CNN based on the architectures tested in this project. Strong combination of fit and accuracy, and really good performance overall. So next steps in this process is to continue improving it. I mentioned a couple times in here, I would like to be able to go through more epochs, and so I plan on doing that for sure, and tweaking parameters, maybe training it with new data. Step 2 is to research, test the model on real world data, pilot it in in whatever use case it is, whether it's in an educational system, mental health, whatever it is. We'll get more into that after this slide. And then step 3 is to implement it, actually use it in a production environment, engineer it into a backend or UI framework. A lot of benefits from implementation. I narrowed it down to 3 main categories: human understanding, mental disorder detection, and virtual assistant. So with human understanding, I really think the possibilities are limitless here. There's a lot of research that can be done using a model like this to understand human behavior, again, given stimuli, right? Just set up a scientific experiment, more efficient computer-human interaction, maybe in an educational setting, again, measuring engagement. The second is mental disorder detection. Using this model on someone who has been diagnosed with a mental health disorder to detect the patterns that are expressed with their facial emotions, as we know that's a big part of communication. We can use those patterns to detect mental health disorders earlier on with people. Remote monitoring of mental health, and then a reduced stigma. Someone can just come interact with AI or a virtual assistant and have a better communication experience because the model is able to understand not just what they're saying, but the facial emotions there. Capping this off with the virtual assistant in a more business environment, it could be a great feedback mechanism for marketing, research, and product design. Put a product in front of someone's face, see how they react. What emotions do they have the first time they see it? What emotions do they have as they're using it or testing it? And then improved issue resolution if an AI virtual assistant recognizes, a certain emotion or pattern of emotions that are happening, that they can maybe escalate it to a human support agent. There's a lot of possibilities that I feel like I could go on. And this is, again, very early stage, but it's been a really exciting project to dive in and really just think about what this could be used for, and I really do think there's a lot of implication for it. I mentioned here step 3 of implementation, of implementing it in a backend or UI framework. I decided to do just that, and because I wanted to use it, I wanted to test it out, see how it works. This is the homepage of this little This is just a local UI using a Streamlit architecture. It's using the model that I trained and tested to give live feedback here. So you can see the framework rate's a little bit slow. Some of that has to do with the zoom. What's happening here is it's capturing images every X amount of times per second, feeding it into the model and taking the output or the prediction from that model and displaying it live, as you can see here. So we can test it out. If I'm just neutral here, I can smile. It says I'm happy. If I'm surprised, like, or if I'm sad, you can see that, it works pretty well. It's accurate. This was cool to see on the live feedback. And so this is just a little spot to just kind of mess with it and see, your own facial expressions. And it's just again, a way to test, all right, what new data can this model handle well. I also made a little analytics section. This was really fun for me. And you can see this was my last session. I'll show you how this works. Just click start session and it's not showing me my face right here, but it's tracking me live right now. And so what I'm missing here is happy, so I'll smile. And you can see in the data visualization updates live. And if we wait long enough, which I will, and maybe hopefully I can talk through this time, the cutoff is 2 minutes. And so once it hits 2 minutes, it's going to switch to a line graph so that you can see not just the total count of each emotion, but also trends using timestamp. So it's also collecting the timestamp of each time the image is fed into the model so that we can look at, time series analysis. Try to be a little bit more happy, positive. Let's see what happens here. So yeah, I'll just go ahead and skip to the 2 minute mark. All right, welcome back. So as you can see, it shifted into a line graph. There's only 2 minutes that have been documented and it tracks it per minute. So hard to see a ton of trends here. But you can imagine over time, these trends will continue to show. And you can leave the browser if I wanted to test what my facial emotions are like as I'm presenting. Like this could be an interview tool or a presentation tool to measure how you're doing in terms of the emotions you're expressing through your face. You could go ahead and put it on and then do a Zoom call to see how you're reacting with your coworkers in terms of facial emotions. So right now it is just those are the kind of use cases I'm thinking because it really is just an experimental kind of fun tool right now, but I can see it expanding more into a production type environment or even just moving forward outside of facial expressions. I know there's IoT things going on right now with what you're looking at welds in a manufacturing plant. There's all kinds of use cases for machine learning, image classification, and this is an example of just time series analysis within that type of framework. So we'll go ahead and stop this analysis session, and it'll give me the final result here. You can see, 88 count of a neutral emotion within 1 minute. So you can see the amount of times that it's tracking facial expressions. It gave me an example of each. So the first face that it saw of me in each emotion, it went ahead and displayed those here at the bottom. Another method that I wanted to implement here was be able to upload a video. I thought that would be cool to maybe something you've recorded. You could just go ahead and upload that. So I have a video here that I recorded not too long ago on my phone. In fact, I'll go ahead and just play a clip of that right here. Yeah, just to show you what it is. Here, I just wanted to come in and express some emotion to feed into my emotion detector. So, I'm super happy. I'm also surprised, a little bit sad. Anyway, you get the idea. So that it's like a 20-second video, but I'm going to go ahead and upload this and let the code feed it through the model. Again, image by image, thousands of times. I'm going to run video analysis. It's uploading the data right now, and it will give me a progress bar showing its progress as it iterates through every single image that it collected from that video and sent it into the model for feedback. This will take just a couple minutes. Okay, you can see here the analysis is complete. Again, same thing, gave me 4 images from the film of an example of each emotion. 174 counts of happy, 284 neutral, 141 sad, and 108 and 7 surprised. So again, if the video was longer than 2 minutes, it would display a line graph to kind of show the time series trend as well. Just a fun tool here, nothing crazy, but it's been fun to kind of experiment with this and use it in a UI framework to make it come to life. This is something that I can kind of play with and use moving forward. So it's been a super fun project to work on. Huge thanks to the faculty and and staff at MIT in the Applied Data Science and Machine Learning program for their help in educating on me on these machine learning models, providing the framework and the data for this project to help me train this model. Yeah, thanks for tagging along.